Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So today's problem is a little bit similar to the previous trick one or trap one questions. We have this M, the lowercase is big M capital, and we have M uppercase, and we're pushing with the force F, but we applied it to the lower body. And they want us to find everything, what force should we apply so this body will start sliding one on top another. And of course, in this case, when we're pulling underneath, from underneath, this body will go faster than that body, and this body will be moving in this direction, and that means the friction would be in this direction. But basically, if you want to go into the same trap twice, we should say, oh, this is when this friction is mu n, and this friction is mu mg, and this is n, and this is y, and this is x, and the body, another force here, mg, and this is lower, smaller body on top, and then you can say x equal F friction equal ma, and you can say that F friction equal mu n, and F friction is equal mu mg, and mu mg equal ma, and this would be wrong, because it would be the same trap as before, because you actually have to do with both bodies. So this force is F, and this friction is F friction. And so for the bigger body, F minus F friction that comes from the top body equals M A2, right? And we can say that F minus mu mg equal ma2, because friction is mu mg, that is the friction between those two surfaces. And we can say that for the upper body, again, we can say that mu mg is, oh, I will do it a little bit slower. F friction for the upper body equal ma1, and we can say that the same mu mg equal ma1, and we can immediately say that from this equation, this is two equations, we can find ma2 equal F minus mu mg, and we can say a2 equal F minus mu mg divided over m, right? And we can say that from this, m is gone, a1 equal mu g, right? And we can say that on one hand it's static, so accelerations are the same. So there are no accelerations between two bodies, no difference, they accelerate. But on the other hand, they're already sliding one. So that's why I use mu mg as a maximum friction force. But now I use that this equals this, and a1 is mu g, and this is F, a2f minus mu mg divided over m big. I multiply both sides by m, or I send this here, and if I say I multiply, this will cancel out, but me would be m big, m capital will be multiplied here, and I receive mu m capital G equal F minus mu m capital G, and I send this all together, and I have mu mg plus mu lower lower case mg equal f, and I have f equal mu g I factor out, and I say m plus m. And this would be the result. This would be the force that should be applied to pull those, when this body will start sliding against this body. In this case, the lower body will move faster than upper body, and the force of friction will be accelerating the upper body, but not enough, as this force minus force of friction will be accelerating this body. The difference between this and this would be more than friction and divided over mass will create more acceleration. That friction alone will create acceleration of the upper body. So again, the trick was the intent, the first intuition, which is wrong, was to say that as soon as f reaches mu mg, well, we will start have sliding situation. This kind of intuitive approach was wrong, and the correct one that this, which is much bigger force, you need to apply when you will have start experiencing this kinetic friction, which means that this is accelerating faster than top. And of course it makes sense. This force mu mg and the ones that we received, it is mu g m plus m. So here m is 10, is here m plus m is 10 plus 20, it's 30. So this force is 3 times more than this one, because it is 30 and this is 10. And this comes from the fact that the portion of this force is applied to this mass accelerates this mass. And then another portion of this through friction is applied to the smaller mass, accelerates the top mass. And then when it all breaks, it's then when this friction, the force is big enough, then this static situation breaks down. And all right. I hope this was those last problems. Those are on a more complicated side of things because they use this static kinetic friction discrepancy in a more subtle, more intelligent way than we all get used to. So don't get despaired if you get lost in this trap. Got into this trap first time, because as I said, everyone does. Me too, and all my friends who are very good scientists build a great scientific career. In grade 10 we all fell into this trap, but we were able to understand and recover. And the thing is, it's not that you make mistake. The real class is how you recover from this mistake. Everyone does a mistake. Doesn't matter what you do, business, technical stuff, skiing, whatever. You always do mistake, but the real class is how you recover from your mistake. I do mistakes here a lot. I recover easily. So should you. And this is just like the art, to be able to recover from your mistake. But I digress. Like, subscribe, bell, put a comment, put a question. Give me your problem, and I'll see you next time. Thank you.